Hello everyone. Welcome back to another lecture on reasoning ability and problem solving. In today's lecture, we will discuss some practice questions in analogy. So let us start. Now, before solving the questions, let us revise the information or the topics that you need to revise in order to solve questions on analogy, specifically number analogy. The first concept that you should be aware about is the difference between odd and even numbers. We have already studied this in our primary classes. So, odd numbers are those numbers that end with 1, 3, 5, 7, or 9. Correct? Similarly, even numbers are those numbers that ends with 0, 2, 4, 6, and 8. Then you should be aware about the concept of prime numbers. What are prime numbers? Numbers that have only two factors, that is 1 and the number itself. For example, if we have a number 7, it has only two factors, 1 and 7. So this is a prime number. You should remember prime numbers of at least 1 to 100. Between 1 to 100, how many prime numbers are there? We have 25 prime numbers between 1 to 100. Correct? Now, how do we start with prime number? What is the first prime number? 2, 3, 5, 7, and so on until 89 and 97. This much information you should know about prime numbers. Then you should know the squares of at least 1 to 30, and you should know the cubes of at least 1 to 20. So this much information should be retained by you. This much information you should know. Okay, so let us start by solving question number 1. Question number 1 says, find a pair of numbers that has the same relationship as the given pair of numbers. So what do you mean by this? First, we will find the relationship in this pair. Okay, and then we have to look at the options and find the same relationship between these pairs. Correct? We have to find a number that bears the same relationship. Now, if I look at this number, 121, this is what? This is 11 square, correct? And this is 11. So if I look over here, this is A, let's say, and this is B, correct? So basically, A square into A minus 1 is giving me B. How? 11 square into 11 minus 1 will be 121 into 10 is giving me 1210. Correct? This is the relationship. This is the relationship, this one, that A square into A minus 1 equals to B, where this is A and this is B. Correct? So now let us check for everyone. If I check for 9, 9 square into 9 minus 1. So 9 square is how much? 81 into 8. It will be how much? 8 into 8, sorry, 8 into 1, 8, and 8 into 8, 64. It will be 648. So this does not follow the same logic. Correct? Let us check for 6. 6 square into 6 minus 1. That means 36 into 5. So 36 into 5, 5 into 6, 30, 3 will be carried. 5 into 3, 15, plus 3, 18, 180. Correct? So this is also not true. Let us check for 7. 7 square into 7 minus 1. So it will be 49 into 6. Correct? 9 6 are 54. So 5 will be carried. 6 4s are 24. 24 plus 5, 29. We will get 294. So this is also not correct. Let us check for 8. If I check for 8, 8 square into 8 minus 1. So 8 square is 64 into 7. Now 4 7s are 28. 2 will be carried. 6 7s are 48. Sorry, 6 7s are 42. And plus 2 will give me 44. So over here, the logic follows. Therefore, answer will be option number 1. 8 is to 448 because it bears the same relationship. This one. It bears the same relationship which is given over here. Okay. Now let us come to question number 2. Question number 2. Find a pair of numbers that has the same relationship as the given pair of number. So similar question. We have to identify the relationship between these numbers and then we have to identify which of the following options bears the same relationship. That means the elements, both the elements has the same relationship that is in this number. So 5 and 35, clearly multiplication of 7. Clearly multiplication of 7 will give me 35. Over here, 7 and 77 is multiplication of 11. 11 and 55 is multiplication of 5. Correct? 3 and 24 is multiplication of 8. And 9 and 45 is multiplication of 5. Correct? So now I cannot see which one has multiplication of 7 because none of them has multiplication of 7. Now let us revise the concept of prime numbers. So what are the prime numbers? Let us write first 10 prime numbers. Okay? First 10 prime numbers. So first 10 prime numbers are 2, 3, 5, 7, 11, 13, then 17, 19, 23. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say 29. So first 10 prime numbers. Okay? Now if you look over here, 5 is a prime number and 7 is the next prime number. Correct? 5 is a prime number and 7 is the next prime number. Over here, if I see, is 9 a prime number? No. Is 3 a prime number? Yes. So after 3, the next prime number is 5. So, but over here we have 8. Correct? After 3, the next prime number should be 5, but we have 8. So this does not follow the same logic. Over here, 11 is a prime number. Correct? And the next prime number is 13. So again, at this position, we should have 13, but we have 5. So this also does not follow that logic. Now let us come over here. We have 7 and 11. So the next prime number after 7 is 11. Correct? The next prime number after 7 is 11. So this is the one that follows the same logic. Answer should be 1. 7 is to 77. Clear? This should be the answer. 7 is to 77. Because this bears the same relationship. It is basically prime number multiplied by next prime number. So basically, if you assume that this is A and this is B, A into next prime number, okay, let me give it a short form, NPM. A into NPM will give me B. A is a prime number, next prime number if I multiply it with will give me B. So this will be the answer, that is option number 1. Okay. Moving on to question number 3. Question number 3 says find a pair of numbers that has the same relationship as the given pair of number. That means this number has a relationship. We have to identify that relationship and then we have to find an option which bears the same relationship. So now if I see 8 and 256, okay, 8 and 256. 256 is basically, we have to find out how it is related to 8. If I divide 256 by 8, let's see if it is divisible. 8 into 3 will give me 24. Correct? I will get 1, 6. So 2 times. Basically, this is multiplication by 32 times. Correct? So now let us check for every number. 7 into 32. 7 into 32 will give me how much? This will be 14. And 7 3s are 21 plus 1, 224. So not the same logic. Over here it will be 32, 320. So not the same logic. 32 into 5 will give me how much? 90. Correct? So not the same logic. And 32 into 9. So 9 2s are 18. 9 3s are 27 plus 1, 28. So not the same logic. So logic of being multiplied by 32 does not follow. Correct? So now let us find another logic. If I see 256, basically it is half of 512. If I multiply it by 2, basically it is half of 512. 512 divided by 2 will give me how much? This is 2 times 2, 4. 1 will be over here, so 5. And then 1 will be over here, so 6. So this is divisible by 2. And what is 512? 512 is basically 8 cube. Correct? So basically, if this is A, this is B. A cube divided by 2 is giving me B. Correct? A cube divided by 2 is giving me B because 8 cube, 8 was A. 8 cube divided by 2 gave me B. 256. Correct? So now let us check for each of them. 9 cube is how much? 729. 729 is not divisible by 2. Correct? 5 cube is how much? 125. It is not divisible by 2. 10 cube is how much? 10 cube is 1000. Can I divide it by 2? Yes, I will get 500. So this is the answer. For 7 also, 7 cube is 343. 7 cube is 343. Is it divisible by 2? No. So this will be the answer, that is 10 is to 500, because 10 cube divided by 2 is 1000 divided by 2, which is equal to 500. So this one follows the same logic. This was the logic. This one follows the same logic as the pair given in the question. Okay. Moving on to question number 4. Question number 4 says find a pair of numbers that has the same relationship as the given pair of numbers. So it should have the same relationship. So now 7 and 24. 24 I can see is not divisible by 7, correct? But since there is a huge jump, I am assuming that we are looking for divisibility or multiplication. So I've told you that whenever you see small jumps between numbers or small changes, you can see, if you see numbers in comparison, you see small changes, basically we assume that it is addition or subtraction, correct? We assume it is addition or subtraction. If you see bigger jumps, if you see bigger changes between numbers, we assume that it is a multiplication or a division, correct? It could be a combination of multiplication, addition, multiplication, subtraction, but the main operation is multiplication or division. And if you have bigger numbers, that means if you have 3-digit number or 4-digit numbers, we assume that either we are looking at the difference, so sum or the difference, or we are looking at the sum of the digits, sum of the digits. So this is basically your approach to solve number analogy. This is your approach to solve number analogy. Okay, this is how you should proceed. So now I can see bigger change. So I am assuming that we are multiplying. Now what should I do on 7 to get 24? So basically if I multiply 7 by 3 and subtract 3, add 3, how much will I get? 21 plus 3 will give me 24. So if this is A, this is B, basically A into 3 plus 3 is giving me B, correct? This is the logic. A into 3 plus 3 is giving me B. Now let us check for the options. Okay, so 30 into 3 plus 3. So 30 into 3 will be 90, plus 3 will give me 93. So not the correct answer. Option number 3, 19 into 3 plus 3. So 3 nines is 27, 2 will be carried. 3 into 1, 3 plus 2, 57 plus 3 will be 60. So not correct. 11 into 3 plus 3. So it will be 33 plus 3, that is 36. So not correct. Let us check for 23. 23 into 3 plus 3. So 3 into 3, 9. 3 into 2, 6. Plus 3 will give me 72. So this one is the one that follows the same logic. Therefore, answer will be option number 2. 23 is to 72. This one bears the same logic, this logic, as the pair given in the question. Okay. Moving on to question number 5. Choose one number which is similar to the numbers in the given set. So we have 3 numbers now. Okay. These 3 numbers are having certain logic, and we have to identify which one follows the same logic. Which one follows the same logic. Okay. So now these 3 numbers are having the same pattern. They're having the same pattern. So we have to identify that pattern. Now when we see 3-digit number, we assume that we are looking for maybe sum of the digits. So let us try that. 9 plus 5 plus 7 is how much? 7 plus 5 is 12. 12 plus 9 is 21. 4 plus 8 plus 9. 9 plus 4 is 13. 13 plus 8 is again 21. 5 plus 7 plus 9. So 12 plus 9 again 21. That means in each of the case, the sum of digits is always equal to 21. Correct? The sum of digits is always equal to 21 in each case. So now let us look at the options. 5 plus 6 plus 2. This is 11 plus 2, 13. 4 plus 7 plus 1. So 11 plus 1, 12. 3 plus 8 plus 2. So 8 plus 5, basically 13. And 2 plus 8 plus 1. If I look over here, 2 plus 8 plus 1 is how much? 11. So in each of these options, I could not see a one, the one which has the same sum as 21. So answer will be actually option number 5, none of the above. Answer will be option number 5, none of the above, because none of these options has the same equal sum equals to 21. If there was another option, let's say 876 maybe. Okay, if there was an option like this, 8 plus 6 is 14, 14 plus 7 is again 876. 8 plus 6 is 14. 14 plus 7 is 21. So then it would have been correct. Basically, this should be option number 5. We have missed this on the slide. But this is, if none of them is true, answer will be option number 5, none of the above. Okay. Moving on to question number 6. We have 282, 354 and 444. We have to choose a number which is similar to the numbers in the given set. So first we have to identify the relationship between them. Again, if I do the sum, 2 plus 8 plus 2, this is 12. 3 plus 5 plus 4 is how much? This is 5 plus 3 is 8 plus 4, 12 again. And 4 plus 4 plus 4. So 4 into 3, 12. So now we have to look at an option which has the same sum. So 4 plus 5 plus 3. So this will be 9 plus 3, that is 12. Okay, this bears the same relationship. 4 plus 1 plus 7 will be how much? 8 plus 4, 12. Correct? 3 plus 3 plus 6. So 6 plus 3 is how much? 9. 9 plus 3, 12. And 2 plus 5 plus 2. Okay. This is also 12. So in this case, we have all the 4 options which sum is 12. All the 4 options sum is 12. So answer will be fifth option, that is all of the above. Because all of the numbers share the same relationship as these numbers. So for the previous one, the answer was none of the above. For this one, it will be all of the above. Okay. Question number 7. Question number 7, choose one number which is similar to the numbers in the given set. So we have 992, 733, 854 and 632. So if I look over here, 992. Basically, if I multiply 9 and 2 together, I will get 18. Correct? And if I find the sum of 1 plus 8, I will get 9. Correct? So here I got 9. Similarly, let us look at 7 and 3. So 7 into 3 will give me 21 and 2 plus 1 will give me 3, which is given over here. Similarly, let's just check for 85. 8 into 5 will give me 40 and 4 plus 0 will give me 4, which is given over here. Correct? Similarly, 6 and 2. So 6 into 2 will give me 12 and 1 plus 2 will give me 3, which is given over here. Okay, so this is the pattern. Now let us check for everyone. 1 into 4 will give me 4. So this is single digit. So here we should have 4. So this does not follow the same logic. 326. So 3, let me write it over here. 3 into 6 will give me 18 and 1 plus 8 should give me 9. So this does not follow the same logic. 425. So 4 into 5 will give me 20 and 2 plus 0 should give me 2, which is given over here. So this one follows the logic. Let us check for fourth also. So 9 into 7. 9 into 7 will be giving 63 and 6 plus 3 should give me 9, not 4. So this one also does not follow the logic. Only option number 3 follows the logic, which is the correct answer to this question. Okay. Moving on to question number 8. Choose one number which is similar to the numbers in the given set. So we have to find which one is similar. Okay. So if I look over here, I can clearly see a pattern. Which is the pattern? First 1, then 2, then 3. So the next number will automatically be 4. Okay. This is the first pattern. Then I see 3, 4, 5. So the next number automatically be 6. Correct? Then I see 4, 6, 8. So 4, 6, 8 are what? Even numbers. So the next even number after 8 is 0. Correct? The next even number after 8 is 0. So the number will be 460, which is given in option number 2. So option number 2 will be the correct answer to this question. Okay? Now, moving forward to question number 9. choose that set of numbers from the 4 alternative set which is similar to the given set. So we have a set over here. First, we have to identify the relationship between these numbers, and then we have to identify which set among the 4 options have the same relationship. Okay. So between 2 and 14, I can see this is multiplication by 7 and this is multiplication by 8. Correct? Multiplication by 7, multiplication by 8. Now let us check the options. 2 into 7 should give me 14. Similarly, over here I will get 16 if it is 2 into 8. So this is not correct. Checking over here, 2 into 7 will give me 14. So not correct. 4 into 7 will give me how much? 28, not 16. So not correct. 3 into 7 will give me 21 and 3 into 8 will give me 24. So this option, that is option number 3, follows the same logic as given in this set. Correct? In this set, we had the same logic of into 7 and into 8. So option number 3 follows the same logic. Therefore, this will be our answer. Option number 3 will be the correct answer to this question. Okay? Question number 12. Choose that set of numbers from the 4 alternative sets that is similar to the given set. So similar type of question, we have this set. First thing, we have to identify the relationship between these set, and then we have to identify which one follows the same logic. Okay, so if I look over here, this is what? This is into 6, and if I look over here, this is into 2. Correct? 3 into 6 gives me 18 and 3 into 2 will give me 36. Or another way is 3 into 6 will give me 18 and 3 into 12 will give me 36. Correct? 3 into 12 will give you 36. This is also another logic. So now let us check for each option. First, we have to check for into 6. So this is not correct. Into 6 will give me 12. So not correct. If I look over here, 4 into 6 gives me 24. Correct? And 4 into 12 will give me 48. Or I can say 24 into 2 will give me 48. So this one is the correct answer. This one will be the correct answer. Now let us check for option number 3 and 4 as well. 6 into 6 should give me 36. So this is not correct. And 12 into 6 will give me 72. Okay. But over here, this should be into 2. So it will not give me 96. So this is also not correct. So the correct answer will be 4, 24 and 48, which is given in option number 2. So option number 2 will be the correct answer to this question. Okay. Question number 11. Choose that set of numbers from the 4 alternative sets that is similar to the given set. So same type of question. Now we have 6, 15 and 28. Okay. So 6 to get 15, basically this is plus 9 and this is plus 13. Correct? 6 plus 9 will give me 15. 15 plus 13 will give me 28. So here let us check. 46 plus 9 will give you how much? 46 plus 9 will give you 55. So this is correct, incorrect, right? 50 plus 9 will give me 59, which is good. And then plus 13, I have to check. So if I add 13, I'll get 72, not 71. So this is also incorrect. Checking for 60 plus 9 should give me 69, not 67. So this is also incorrect. Coming here, 60 plus 69, so plus 9. And from 69 to 82 is plus 13. So this one will be the correct answer. That is option number 4. Option number 4 is the correct answer to this question. Okay. Now, moving forward to question number 12. Choose that set of numbers from the 4 alternative sets that is similar to the given set. This is the set. 81, 77, 69. Okay, 81, 77 and 69, we have to find out which one follows the same logic as this set. Now, if I look at over this number, this is minus 4 and this is basically minus 11. Correct? This is minus 4 and this is, minus 8. This is minus 8. 77 minus 8. This will be 6, this will be 17, this will be 9, this will be 69. So this is minus 4 minus 8. So now let us check. 56 to 52 is minus 4. And 52 to 44 is how much? 52 to 44 is basically 52 to 44. This will be 4, this will be 12, this will be 8. This is minus 8. Correct? Now, over here, if I look 75 to minus 4, but this one is minus 11. Correct? This one is minus 11. Over here, minus 3. So don't proceed. Over here, how much we have? Minus 4. Correct? We have minus 4. And from 88 to 79, if we are going, this is minus 9. This is minus 9. So the only one that follows will be option number 1. That is 56, 52 and 44. Correct? This one will be the correct one. Now, question number 3. 32, 24 and 8. Okay, 32, 24 and 8. So 32 to 24 is how much? Minus 8 and this is minus 16. So now let us check. 24 to 16, I can clearly see this is minus 8 and minus 16. So this will be the answer. This will be the answer. Clearly, I can see 24 minus 8 will give me 16 and 16 minus 16 will give me 0. Okay, here it was addition. Here it was minus 10. And here it was minus 12. Or sorry, minus 12. Minus 8. So again, does not follow the same logic. So answer will be option number 3. Question number 14. 9, 15 and 21. So we have to first find the logic. So 9 to 15 is plus 6 and 15 to 21 is plus 6. So plus 6 plus 6. This one is plus 4. This one is plus 5. This one is plus 14. This one is plus 6 and this is also plus 6. So answer will be option number 4. Correct? Option number 4 will be the correct answer. Question number 15. Question number 15, 21, 51 and 15. Okay. So now if I look over here, 21 is 3 into 7. 51 is how much? This is also multiple of 3. What is the divisibility rule of multiple of 3? Divisibility rule of 3. Divisibility rule of 3. Basically, the sum of digits should be a multiple of 3. So 5 plus 1, 6 is a multiple of 3, correct? So 1 plus 5, 6 is also a multiple of 3. So these are all multiples of 3, correct? These are all multiples of 3. If I check over here, 21, 30, 51. These are also multiples of 3, correct? These are also multiples of 3. Over here, 21 is a multiple, 35 is not a multiple, and 41 is also not a multiple. Over here, 21 is a multiple, 91 is not a multiple, 35 is not a multiple. Similarly, over here, 31 is not a multiple, and the rest two are multiples. So, in this option, that is option number 1, all are multiples of 3. So, this will be the answer. So, this concludes today's lecture. Thank you.